video will be on how you can convert from the decimal system into the binary system and the hexadecimal system. All number systems follow the same rules. N is which base you are working with. N to the 0 power is the first position of the number. Then comes n to the first power, n to the second power, n to the third power, and so forth. So what does this mean? Let's look at a system you're familiar with, the decimal system. In the decimal system, n is equal to 10. In other words, we're working with base 10. 10 to the 0 power is equal to a value of 1. 10 to the first power is equal to a value of 10. 10 to the second power, 100, then 1000, and so forth. You may remember this from elementary school, where the first position of the number is the ones unit, then the next position is the tens, the third is the hundreds, and the fourth is the thousands. When you're writing a number, for example, 2,134, each position has a value. So if you wanted to convert the number, 2 is in the thousands position. So it's 2 times 10 to the third, which is 2,000. The 1 is in the hundreds position, which equals 100. 3 is in the tens position for 30, and 4 is in the ones position. That equals 2,134. This may seem really obvious, but as we move on to the binary system, you will see that the steps that we take are exactly the same. When using the decimal system, the number values you can use range from 0 to 9. In other words, at any given position, you can use the number 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Once you've reached the end of the sequence, you will have to move over one position. That's the reason that the number 10 is actually 2 different digits, a 1 in the tens position and a 0 in the ones position. Now let's look at the binary system. In the binary system, the base is 2. This means that we only have 2 values that we can use, a 0 or a 1. So in any given position, you can only put zeros or ones. Binary is very common when you're working with a computer or other electronic devices. They cannot actually read any values such as words, letters, or characters. They can only read in binary. So how can we convert numbers into binary? Let's start with this example. If you had the number 1, 0, 1, 0, what does that mean? Just like before, the first position is the base to the 0 power. The second position is the base to the first power, base to the second power, third power, and so forth. This means that 2 to the 0 power has a value equivalent of 1, 2 to the first power, value of 2, 2 to the second, 4, 2 to the third, 8, and so on. Let's look at what 1010 would mean. Well, the 1 here is in the position of 2 to the third power with an equivalency of 8. Then there's no number here, it's a 0. Then this one is in the position for 2, and then there's a 0. 8 plus 2 equals a value of 10. This means that 1010 in binary is the equivalent of 10 in the decimal system. You can find out if your Arduino code is using binary because before the binary digits, you often see the capital letter B. So you could have seen something like this, B1010. Now try these examples below. You can pause the video and try it out for yourselves, then come back to the video to see if you were correct. Let's look at the binary 0011. In this case, there's a 1 in the second position and a 1 in the first position. This will add up to 3. So in binary, 0011 is equivalent of 3 in the decimal system. Now how can you work backwards? That's going to be a lot trickier. When trying to convert from decimal to binary, I suggest you start by creating a chart showing the first 4 positions in binary, which are 8, 4, 2, or 1. Take a look at the number that you're trying to convert. The number right now is 4. Is 4 greater or less than 8? It's less than 8, which means there's not going to be any number in the position for 8, so we fill that in with a 0. Next is the digit for 4. 4 is equal to 4, so we're going to put a 1 there. That means the other 2 must be 0 as well. So 0, 1, 0, 0 in binary is equivalent to 4 in decimal. Try the last 3 conversions on your own, then check back with the video to see if you were correct. 0101 in binary is equivalent to 5 in the decimal system. 1111 is equivalent to 15. And finally, 8 ones in a row is equivalent to 255. Now we're ready to look at the hexadecimal system. Hexadecimal means that the base is 16. Previously, when the base was 10, we could use the digits 0 to 9, which are 10 different digits. However, now we need 16 different symbols. We can no longer just use numerical symbols from 0 to 9, because if we wrote numbers like 10 or 11 or 12, we'd actually be using 2 digits, which would make it very confusing. So instead, we use A through F to refer to the last 6 digits, which are 10, 11, 12, 13, 14, and 15. Let's try an example. 0, 1, 2, E. 0 is in the position of 16 to the 3rd power. 1 is in the position of 16 to the 2nd power, which is the equivalent of 256. 2 is in the position of 16 to the 1st power, so 2 times 16 is 32. And finally, E is in the 1's position. If we come up here, we can see that E means 14. So add up 256, 32, and 14 to get the value of 302. In other words, 1, 2, E is equal to 302 in the decimal system. When using the Arduino program, hexadecimal digits will often start with 0x followed by the hexadecimal. Now you try doing the conversions below. Pause the video and give yourself a couple of minutes to try to figure out the answers. How would you convert 3C? 3 is in the 2nd position, so that's 3 times 16. C, which is the equivalent of 12, is in the 1's position. 3 times 16 is 48, and 12 times 1 is 12. If you add it up, you get a value of 60. So 3C in hexadecimal is the same as 60 in decimal. Just as we did with the binary system, when converting from decimal to hexadecimal, I suggest you create a chart. So write the value 256 or 16 to the second power, then 16 for 16 to the first power, and finally 1 for 16 to the 0 power. When we look at the number 112, it's clearly less than 256, so we can put a 0 there. How many times does 16 go in to 112? The answer is 7. 7 times 16 is exactly 112, so there's no remainder, which means there's 0 in the ones position. 112 in decimal is the equivalent of 70 in hex. Go ahead and finish the last couple of examples and then check back with the video to see if you got the correct answers. 11a in hex is 282 in decimal. 526 in decimal is 20e in hex. And finally, 20f in hex is 527 in decimal. This last one makes sense because 20e and 20f are almost identical, and up here we know that e and f are only different by one number. So if computers always actually use binary, why do we have to learn hexadecimal? Well, after a while, the binary code gets quite long. Imagine writing a number like 1, 0, 0, 0, 0, 0, 1, 1, 1, 0. This is a very long number in binary. It would be very easy to make a mistake and put a 0 or a 1 in the wrong place. If you're even one digit off, it would be a completely different number. This number is the equivalent of 526 in decimal, which is written as 20e in hexadecimal. It is much easier to write 20e than this really long binary number, and you're much less likely to make mistakes.